We recently explored using reinforcement learning to automate red teaming. The idea? Train an attacker model to jailbreak a defender model, then train the defender model on those attacks to strengthen its defenses, and then repeat. In this video, I'll walk through how you'd run this on castform. First, going over the experiment design on a high level, we train the model over multiple rounds with 2 phases each. In the first phase, we train the attacker to jailbreak a defender model. Then, we train the next iteration of that defender model on the newly trained attacker plus all previous attackers. We also include some benign examples so the model doesn't just learn to reject everything. First, let's go over how we set up training for the attacker. Step 1 is the dataset. We load behaviors from the harm bench dataset and filter it to the categories that we care about for this training run. And then we form them into goal prompts and ground truth pairs. Basically, the prompt is just telling the attacker model, you need to get the attacker model to do the following, and then the ground truth is the goal that's in the harm bench dataset. Then we split it into an 80-20 split for training data and eval data. Next step is the environment, which defines what the model can do and how it's evaluated. There's a lot of code here in terms of the judge prompts and the helper function, so we're just going to skip them and do a high-level overview. So here's the attacker environment. As you can see, we set up the system prompt here, and we give the model tools that it can use. For this example, all that we really need is a tool for the attacker model to send a message to the defender model. Then in terms of rewards, this essentially is our success metrics that define what the model actually is going to optimize for. In this case, we want to optimize the attacker model to jailbreak the defender model. So we define 3 rewards here. First is engagement. This was something that we had to add to nudge the attacker model out of its initial safety training. Then we have our classifier, or classified jailbreak. This basically calls the harm bench classifier and gives it a half reward if it does pass. The reason it's just half is because we found a lot of false positives here where the classifier would say it was a jailbreak even though it wasn't. So because of that, we added a 3rd reward, which is the verified jailbreak reward. This essentially is just calling an expensive LLM judge like GPT-5, and it's only called when the classifier fires to basically confirm whether or not this was a true jailbreak. And then from those 3 rewards, we compute the group reward, which essentially is at the group level, we cluster the different strategies and divide rewards by cluster size so the model doesn't just collapse to one tactic, essentially a diversity reward. You'll want to validate. So once you have your environment and dataset ready, you'll want to do a validation run before you actually submit a training run. Then you will want to upload the environment bundle and dataset to our platform, and then you can call launch training run to actually submit the job. Okay, now the defender. Essentially same structure, dataset, environment, validate, and launch. For the defender case though, the dataset needs to be richer because we want the model to defend against a variety of attacks as well as retain its general capabilities. So for this case, for the attacker side, we load attacks from all previous attacker checkpoints, not just the latest one. And then we also generate boundary benign prompts that look like attacks but are safe. And then we add capability tasks like math to keep the model useful. Everything gets assembled together in the same data set that the model will be trained on so it can train against a diversity of prompts. Now scrolling down to the environment, it's essentially a very similar setup. The model is given one tool. In this case, we call it the response tool, which basically allows it to respond to either the attacker model if it's given an attacker prompt, or to a safe model if it's given a benign prompt. In terms of the rewards, because there's different types of prompts, we have different axes we want to evaluate the model on depending on the prompt. So for this case, we actually split the rewards into 4 pieces. First is the format reward, which is similar to the engagement reward for the attacker, just getting the model to actually call the tool call correctly. And then we have correctly refused and correctly helped, and these are evaluated depending on the prompt that was given. And then we have the capability correct reward, which is for the benign tasks or tasks that are asking the model to actually do something, did it do it successfully? And then again, once you have the environment dataset set up, we'll validate, we'll upload, and then we'll launch the training run. Once you've started the training run, our platform gives you observability into reward curves and rollouts as it trains. This is the first iteration of the attacker. You can see here that the attacker learned to break the defender model over time and plateaued. Below the charts, you can deep dive into any prompt and each rollout to understand model behavior and debug any issues. After enough training steps, you can switch over to the Eval tab to ensure that the model is not overfitting. Over time, the defender model successfully learned to decline any attacker's requests. For this experiment, we ran 2 rounds of code training and saw each round improve defense rate while benign accuracy degraded slightly. We saw that the attacker learned a diversity of different tactics, and the defender evolved to defend against all of those different tactics. I hope this showed you how RL and our platform can be used to increase model safety against a diverse range of attacks.